perspective and orthographic drawings. So in the real world, it's a technician's job to represent 3D objects on paper. And we know that paper is 2 dimensions, right? It's length and width only. Okay, and these people work alongside such people as architects, engineers, to design structures, building, and machinery. So let's take a look at types of drawings. Okay, so isometric drawing shows the 3 dimensions of an object, but on 2 dimensions, which is like a piece of paper. Right? And we're going to be studying orthographic drawings. So this is a drawing that shows the top, front, and side views of an object. Okay, in this type of drawing, each view is usually drawn so that the edges line up, so that they're like matching edges on the views. Okay, and we're going to use different types of paper. So we're going to use isometric dot paper, normal dot paper, right, and grid paper. So if we take a look, dot and grid paper like kind of line up in 90 degrees, right? But isometric are on angles. We can take a look there. Okay, so let's take a look. The first example that we're going to look at is an isometric in orthographic design. Okay, so Tony is making an isometric and orthographic design, a drawing of a classroom chair. Okay, so let's take a look at that isometric drawing first. So what you want to do first, and remember, isometric drawing is drawing something 3D on like a 2D plane or on like a piece of paper. So this paper right here, this is the isometric dot paper. So what he's going to do is he positions the chair so that one of the front corners faces him, which is this corner right here. Then he's going to follow these steps. So I have the picture here, but let's go through the steps and actually like trace over the picture. Okay, so first we're going to draw a vertical line to represent the metal pipe that runs from the floor to the top of the back of the chair. So that's going to be this one. Okay, then we're going to draw 2 parallel horizontal lines going up to the right to represent the backrest. So here's the backrest right here. And of course, like this spot right here where I'm arrowing, that's going to be open. I'll delete the arrow. Okay, then we're going to draw a vertical line to represent the metal pipe that runs from the top of the backrest to the seat. And of course, this would continuously go down if we could see through, if we had like x-ray vision, but I'm going to delete that. So we're just going to include this aspect of it. I'm going to draw a horizontal line parallel to the lines on the backrest. So the edge of the seat, it's obviously going to be squared up to the backrest. Okay, then we're going to draw the right and left edges of the seat. And then we're going to draw the legs of the chair. Okay, and that's how you would draw an isometric drawing of a classroom chair. Now, same thing, classroom chair, Tony needs to draw an orthographic drawing. And just to recall, sorry, so many buttons on my tablet. Okay, just to recall, an orthographic drawing is drawing the top, the side, and the front view, and connecting them, okay? So, oh, we have that here, top, side, and front. So, draw what you see each time, and, oh, this is position, sorry, position the drawings so that the matching edges line up. So, let's take a look. From the top, if we look straight down on the chair, all we're going to see is a square. Right? Because the backrest is going to be, for example, like right here. And the chair is going to be underneath if we look. Okay? So this is going to be from the from the top. Now, from the front or from the back here, what we're going to see is we're going to see these 2 legs. We're going to see the seat. And we're going to see both arms up, and then we're seeing the backrest. Those would line up. And then from the side, we're going to see the backrest all the way down, the seat, and then one leg of the chair, because the legs of the chair would be behind one another. And that's how you draw an orthographic drawing of a chair. Isometric and orthographic drawings. So let's consider a rectangular prism with the dimensions 3 by 2 by 1. Okay, let's sketch a drawing of this figure. So when I think about a rectangular prism, I think of something that looks like this. And maybe we can say 3 by, maybe this is 2 by 1. Yep, so length, width, and height. Okay, so now compare what yours looks like or what you were thinking to this. How do they compare? Now we're going to investigate 3 possible ways to accurately represent this figure. So, isometric drawing. An isometric drawing, again, it's a 2D representation of a 3D figure. Okay, so the drawing kind of looks 3D-ish as though like the 3D figure has been rotating. So like that corner view, and we saw this in the chair, this corner view right here is facing us. Okay, so we can see the top, we can see the side, and we can see the front. Okay, and this is what a rectangular prism would look like if we used one of these units for, what do we use? A meter. So 1 meter. So we'd have 1, 2, 3. So this purple would be 3 meters in length, right? And then the blue, let's go the blue. These 3 would be 2 meters, so 1, 2. And then let's go green. So 1, 2, 3, and those all would be 1 meter in length. Okay, the scale must always be stated or the dimensions should be shown on the drawing. So try to create an isometric drawing and draw the edge of the sides of the object alongside the angled lines here in this isometric dot paper. Okay, each line segment of the line is related to 1 unit of measurement. So in this example below, we have a unit of measurement is in meters. So we have 2 meters by 4 by 5. So we know, so let's go 2 is the length, and then 4 is the width, and then 5 is the height. So we know that right in front of us is going to need to be the front edge. So let's start it here. So it was only 2 meters in length, so maybe 1, 2, and then 4 meters width. Let's draw this. I'm going to draw it lower because, so 1, 2, because we know we're going to have a height of 5. Oh, that doesn't work. I'll show you why that doesn't work, because 1, 2, 3, that wouldn't work. Okay, let's try it from here. 1, 2, this is 2, 1, 2, 3, 4, and then height of 5. 1, 2, 3, 4, 5. Oh. There we go. Okay, I would go to every vertex and go up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and then connect them again. 1, 2, 3, 4, oh, 5, and then connect them again. So that would be 2, that would be 4, okay, and then 1, 2, 3. We need one more dot. No problem. There we go. 2, 4, and 5. Okay, now let's take a look at orthographic drawings. So this is, again, a 2D representation, and we're going to display our rectangular prism, so our box, from the top, the front, and the right side. Okay, so from the top, this is going to be connected to our nets, which we're going to do in like one of the next sections. Okay, so we know that our original drawing was 2 by 3 by 1. So we can see a 2 by 3 here. There's going to be every single combination. There's going to be a 3 by 1. So this is 3 by 2. This is 3 by 1. So both 3's are used. Now there's going to be a 1 by 2. So every single combination is used when we draw a rectangular prism. orthographic drawing, you need to complete an individual scale drawing of each, like the top, the front, and the right views, right? You don't really have to do these dotted lines, but they have to line up, so that's fine. You can do them if it helps you line them up. Okay, so we have to line these up. This is views. These three views have to be oriented so that the edges line up. You see like how this across is 3, so the one down here has to be 3, and this across is 1, so the one over here has to be 1. Okay, so try to draw a 2 by 4 by 5. Okay, so if we're looking length, width, height, if we look at the top, it's going to be length and width. So let's do a 2 by 4 at the top. So this is 2, 1, 2, 3, 4. 2 by 4 at the top. This is 2 by 4. Now, the front is going to be 4 as well. So maybe we can just go across here. It's going to be 4 by 5 this time. 1, 2, 3, 4, 5. 4 by 5. And this 5 is going to be used again here. So let's just go over 2. 5, and what are we missing? A 2. So it's going to be 5 by 2. Okay, so there is an orthographic drawing of a rectangular prism that has the dimensions 2 meters by 4 meters by 5 meters.